Yeah, yeah. Today we're going to talk about how secure RSA is.
This morning we have witnessed some presentation on RSA, how to generate the keys, how the keys works, the public, private, and then how to encrypt and decrypt. However, now we are going to try and challenge and then see the challenge out there to break RSA by seeing how secure it is. Because as we might know, there is nothing 100% secure. Just because it's made by human, it might be a backdoor or a bug left out. So now we're going to quickly go through and then try and explain if RSA is secure, until what point. Okay, we're going to be focused a bit more in quantum computing, which is a more exciting topic to talk about.
So yeah, quantum computing and Shor's algorithm. Well, quantum simply means taking something in its smallest units. So quantum computing would be like computing with atoms.
In more specific case, because we know classical computing, the computers we use nowadays, they are measured in bits, 0 and 1. But when it comes to quantum computing, it's in qubits, which is quantum bits. So this is the fact that it does have two of its properties, which is one of them is superposition and then one of them is entanglement, which means that the bits can be 0 or 1 depending on on the opposite. This transposition means that it can be both of them, which allow you to process data in much faster and a much reliable way.
Yeah, the special characteristics of Shor's algorithm is on a quantum computer is integer factorization. So given n was 7,663, it would return p and q in polynomial time, but it will return in polynomial time, but it will be outside of p.
Okay. As we know in classic computing, to compute like a large prime number, to factorize it is a bit difficult. It's big O is in exponential function, which means like it exists, but you might never find it. So when you calculate in quantum computer, it's quite easy to find sometimes by using up to 4 qubits, just 4 qubits, which is large compared to classical computer. You can decrypt, you can get the key or decrypt anything encrypted in RSA in just a short time, because it has ability to factorize large prime numbers. It is estimated that by 2030, even 4,000 bits would be able to break, would be able to be decodified decrypted using quantum computing.
Every time you add a qubit to the computer, it doubles the processing rate. Yeah.
Regardless of the quantum computing, RSA has already been proven that it can be broken. One of the one of the co-founders of RSA, which is Shami, he was part of one team that successfully decrypt or get the keys. How do they do it? They use noise, which, as we know, processors, they make noise. And by doing so,
it's called a acoustic cryptanalysis attack. What it does, it listens to your CPU as the RSA is being decrypted. And then from this noise, it can decipher what your encryption key was and decipher your RSA. This was achieved by a listening device. It could be a mobile phone within 4 feet, a parabolic microphone, or a laser listening device. If you'd like to know how this was achieved, go back to the math. Right?
Just technical issue.
Go back to the math.
No, Yeah, this is one of the devices used to get the key through the noise your computer make normally. By using these parabolic microphones or even a normal smartphone, you can catch the frequencies which is emitted through the key, which will catch the key. This is independently of like getting password of someone by getting the noise of the keyboard. It's completely independent. In this case, it's capturing the noise and then extracting the key. As you can see, these are the bits and bytes the way they're represented normally. Attacks bit and then attacks bit 1 because it's just a variation of 1 or 2. So if they catch how they vary, they can easily get your key back. Yeah. You're back again.
Yeah, so this is how the quantum computer actually breaks your code. Firstly, it chooses a random number that's smaller than n, and we call it A. Remember that quantum computer it has qubits. It doesn't use bits. Where a standard computer does bits, it will do one, then 2 calculations. A quantum computer has, let's say, a sigma of to do the decryption, or to do the calculation. It will do it in a sigma. It have loads of bits in a line. And from that sigma, it needs to calculate R. So to achieve this, if n was 7 and A was 2, like I said, it's in a sigma. 2 to the power 1 mod 7 is 2, 2 to the power 2 mod 7 is 4, 2 to the power 3 mod 7 is 1. Now, the period will be 3, right? Because every time it gets back to 1, that equals a period. So once it has a period, then the calculation should be A to the power of R divided by 2, not equal to mod n. This should return your P and Q.
Yeah, as you can see, it's RSA is secure.
To an extent.
Yeah, but until what point? Because this is just the 2 of the methods that I use it to break it. How many of them might be out there? What is in risk? There are so many studies to be made in order to find the new algorithms or to automate these algorithms, because computers are never going to stop being built in the best and then best quality. So we do not expect that someone is going to break it using the normal computation, classic computation, so unless by catching the noise or other stuff. But is it possible that there might be so many methods to use it to break RSA?
So your RSA is still secure to a point that if you have the power and the technology and you have a phone maybe sitting next to your computer, it might not be secure. That's it.
Okay, this is all. Any question?
Okay.
Okay,
Thanks.
thank you.